All right, this is the last lesson of the unit, Unit 3. So this is, we're wrapping it up here. The learning targets here, I can identify the pattern to get from the domain to the range, and I can write a function rule from the table or situation. So in this lesson, we're going to work backwards from what we've been doing so far. So we yesterday, we gave you the rule, and we said fill out the table. Well, here we got the table filled out for you. You got the x's and the y's, and we're saying what was the rule? What told you what to do with 0 to get 3? What do you do with 2 to get 5? What do you do with 4 to get 7? Okay, so we're going to kind of go the opposite direction. And again, you are going to find the function rule. So instead of us giving it to you, you're going to find it. In the following table, it's identify the patterns, or the pattern that gets you from the domain, the x's, to the range, or the y's, okay? And then use a pattern to write the function rule. So I think we gave you some of these, but it was multiple choice on your Math Excel. So you've seen this. Well, now we're not going to give you multiple choice because you had like 6 options. You read through all of them to see which one was right. Here you got to come up with it on your own. And on some of these problems, it's going to click right away. You're going to look at it. Pattern's going to, boom, you see it in your mind, ready to go. Other times you're going to spend a couple of minutes looking at it and you just can't find it. And that's okay. We just got to keep trying. Eventually we'll be able to show you next unit a little bit faster way if it's linear, if it's going up by the same thing every time. It's got some shortcuts to it. But for right now, just kind of guessing and checking in your mind what some of the different options that it could be. So looking at the first table there, think what could I do to go from 0 to 3? Okay. Now you can't multiply 0 by anything to get 3, so it's not a multiplication, but I could add 3. So if I took 0 plus 3, I get 3. So if I add 3, do I get 3? Yes. What if I do that with all of them? Is 2 plus 3 5? Is 4 plus 3 7? Is 6 plus 3 9? In this case it is. So this one was kind of an easier one to see. So the pattern is you want to add 3 to x to get f of x, which is your y. There's just kind of a fancy name for your y. Okay, so that means the function rule would be f of x equals add 3 to x, x plus 3. Okay, so that's your function rule. Number 2, again, we look at here 0 to 0. So you might think, well, I'm not doing anything. It's just x equals y, 0 equals 0. But then the next one, 1 does not equal -4, 2 does not equal -8. So it's not that whatever x is, y is. Or you could say maybe I need to add something. Well, 0 plus nothing is 0. 1 plus 0 is not -4. So it's not an addition. What if it's a multiplication? Well, 0 times anything is 0, so that first row is not really that helpful. It could be anything. But is there something I multiply 1 by to get -4? Well, it'd be -4. So if I multiply by -4, does that keep going? So if I took 2 times -4, is that -8? Yes. If I took -3 times -4, do I get 12? Yes. So the pattern on this one is I'm going to multiply x by -4 to get f of x, which this is also true up here. I didn't write it. 0 times -4 is 0, so that one works. Now, the function rule then, multiply x by -4, so -4 times x. That's my function rule, okay? So that one took a little longer to find. This one was pretty quick, just kind of looked at it, and you can see the pattern just adding. And typically the ones that are just simple additions are easier to see. The ones that are multiplications are a little bit harder to see. Okay. Number 3, again, think how can I get from -2 to -7? Okay, so you might think, well, I could subtract 5. How about 4 minus 5? So subtract 5, subtract 5. 4 minus 5 is -1. 6 minus 5 is 1. 9 minus 5 is 4. It is working. They're all -5. So the pattern is subtract 5 from x to get f of x. So that means f of x would be, subtract 5 from x, so it would be x minus 5. Okay, not 5 minus x. Don't want to do that because you're subtracting 5 from x. X is first, x minus 5. And then this one, trickiest one on here for sure. You think, how do I get from 0 to 15? You might say, well, I added 15. Well, but 5 plus 15 is not 10. And 10 plus 15 is not 5. And it's almost like as x is going up, y is going down. So it's not that you're adding something. They're kind of like doing an inverse relationship here. But maybe another pattern, hopefully maybe you're noticing, if you pause and, if we said look at this for a few minutes, I bet somebody would notice that all of these, if I add them together, I get 15. 0 plus 15 equals 15. 5 plus 10 equals 15. 10 plus 5, and so on. So all of these, x plus f of x equals 15. So kind of the pattern here is that when added, sorry, that's kind of running together, x and f of x equal 15. Come up. Now in this one, I want f of x by itself though. So how do I, in this equation, how do you get f of x by itself? Subtract x from both sides. Okay, so f of x would equal 15 minus x. And there's your function rule. Okay, so that one's a little bit harder to see. We're not going to throw any of those on you on a test or a quiz and try to really trick you or anything, but it's good to see those kind of things and recognize that that's a thing that can happen. In problem number 4, so this problem, what is f of 20? Well, the fastest way to find that would be take my function rule and plug in 20. Remember, these are directions. This has nothing to do with the actual math problem. This is directions. This is plug in 20. This right here is the actual math problem. So 15 minus 20 is negative 5. Now it says, what is the x value when f of x equals 3? So when f of x equals 3, so if I take out f of x and I plug 3 in its place, this is what it's asking. Okay, so you're basically, instead of plugging in for x, you're plugging in for y, which is the f of x. So if f of x equals 3, take out f of x, put 3 in its place, and now solve for x. So if I subtract 15, that'd be negative 12 equals negative x. So, whoops, x would be 12. Okay, or they might be thinking, if f of x is 3, what do you add to 3 to get 15? It's 12. Okay, so that's because we know when added, x and f of x equal 15. Okay, now backside. Backside's word problems. We shudder when we see word problems, but don't get too nervous, okay? And, especially this is the kind of stuff that's on standardized tests that they want you to be able to put real world behind it. So a cup of frozen yogurt at Yo-Yo costs 49 cents per ounce, and we want to write a function rule to determine the cost. So instead of using f of x, I'm going to use c of n. So cost with respect to the number of ounces. So cost with respect to the number of ounces. So the cost, how do we find the cost depending on the number of ounces? Well, each ounce costs 49 cents, so it'd be 0.49 times the number of ounces. Okay, so if you know the number of ounces, multiply by 0.49, that equals the cost with respect to the number of ounces. That's all that really means. In parentheses is with respect to this, whatever n is, whatever the number of ounces is. So in these two kind of problems, you can either plug in for n, or you can plug a number in for cost, because our two variables are cost, final cost, and number of ounces. That's my x. So this is like my x, this is my y. So I can give you an x value, you can solve for y, or I can give you a y value and you can solve for x. How much would a cup that weighs 8 ounces cost? So the cost I don't know, but I do know the number of ounces. 0.49, I'm going to plug in 8 and for n. Okay, so 0.49 times n is $3.92. Just multiply those two together. Asking a little bit backwards now, I said how many ounces? So I don't know. 0.49 n, I don't know what the n is, but I do know the cost. The cost is $6. So for c of n, I plug in 6, okay, for the cost. and now solve for n. So how many ounces could you buy if you had, so say you have just $6 in your pocket. So if I divide by 0.49, then n equals 12.24. Now I'm assuming, let's just say that they sell it by the ounce, because it said how many ounces. So we'll say how many whole ounces would it be? Well, I could do 12, I could afford that, but if I get a 13th ounce, that's going to cost too much, because 13 times 0.49 is going to be over $6. So we better stick with just 12 ounces that I could buy. Now if they let you get hundredths of an ounce, that could be your answer. You'd say 12.24 ounces. Renting a hot air balloon. So let's say the cost is $200 plus $21 per hour. So the final cost, C of H, and that just means the cost depends on the number of hours, is going to equal, no matter what, $200. That doesn't depend. So it doesn't matter how long you have it, you got to pay at least $200 up front, plus $21 per hour. Okay, how much would it cost for 6 hours? That's an hours that goes in for H. So the cost would be 200 plus 21 times 6. Okay, put that in the calculator, you get $326. But now they're going the other way. Let's say you have $400. That's how much money you have, and they want to know how many hours. So I don't know what H is, but I know that I have a $400 bill in my pocket, or 4 $100 bills, and I want to figure out how many hours could I rent this for. Okay, so solving for H, subtract 200 equals 21H divided by 21. So H equals 9.52. You know, we don't know how many hours, so we're going to rent it by the whole hour. I could do 9 hours. I could do 9.5 hours, but I can't do half hours. If I do a 10th hour, it costs too much. So 9 hours is going to be the maximum on that. Okay, so make sure you check the validity of your answer and round correctly. This would say round up, but in this real life situation, I can't round up. Write a function in the change you get from a $20 bill when purchasing items that cost $1.25 each. Okay, so we didn't really label, we didn't say, up here we have C of H is final cost. Down here we didn't do that. So let's do that ourselves. We'll say a really good letter for change would be C. Again, that's not cost, now it's change. The change, what does the change depend on? It depends on the number of items we buy. So I'll put an N for number of items. So this is the change from using a $20 bill, and then N is the number of items, number of $1.25 items that I'm buying. Okay, so the change I get, well, to find out my cost, I would take $1.25 times the number of items, and then I'd take that away from the $20. If I ring this up and I give them a $20 bill, they're going to take 20 minus what my total cost was. Okay, so this gives me my change then left over. So how much change do you receive when you purchase 5 items? That's a number of items, so plug that in. So C of 5 would equal 20 minus 1.25 times 5. Okay, put it all in the calculator, it's $13.75. And then kind of change things up a little bit here. Can you purchase 17 items with a $20 bill? So we want to know, if I buy, let's see, 17 items, what would my change be? So what is my change? Now, if I get change back, that means I can purchase this. If I don't have any change left, say it's in the negatives, that means it costs too much, and the cashier is going to be waiting for more money from me. So if I put this in the calculator, this actually equals, sorry, this should be a 17 here, negative $1.25. It's too many items. Okay, so my cost is more than the $20 bill I got. So no, the cost is more than $20. Okay, so that is the end of the unit. There's only 5 days on this one, so this one, the tests hopefully won't be as hard. It's only over 5 days worth of material, and we're going to wrap this up. We're going to do a little quiz when you guys could get back from your flex day. Come back next week, and yeah, then we'll go over the quiz and we'll have a test and start Unit 4.